to another spaceexplr episode. Today is going to be a very special episode, as the rest of the episodes, and because we have another very special guest, and his name is Michael Wilson. Michael is amateur astrophotographer, nightscape photographer, and occasional solargrapher. I don't know if I said that right, but he began doing this astrophotography in 2018. And again, besides that, he's a microbiology scientist as well. And again, you should follow Michael again and his work on Facebook, Instagram, and Twitter, which of course, all these links are going to be included in the show notes. And Michael, again, thanks for coming over today. I really appreciate it.
Thank you very much for having me.
It's a pleasure. It's a pleasure to connect. I'm very happy that, again, it's a quick note for the people who are watching or listening to the episode. If you want to kind of pick somebody's brain or make connections, go to the Instagram, because we connected with Michael through Instagram, and we'll make it quick. I asked, can we make this possible interview happen? He said, yes, of course. So here we go. Here we are. So Michael, for your question, can you talk about your kind of personal background? And maybe how did you get involved with microbiology, as well? And how did you transition from there to astrophotography in 2018?
So I've always had a passion for biology generally. I mean, it's something that runs in my family. The doctors and people who have done science-related things with biology. And it was, when my family became aware that it was a passion of mine, they fed that passion. They sat me in front of lots of biology documentaries, human body documentaries, and I became very interested in the human body as a young child, and it affected how I wanted to go down the road with my studies, high school, college, university. I did originally want to be a doctor, but then it became apparent as the years went on and I went through my education that, no, I'm not really cut out for that. So I went down more just general biology studies, and I got to university, and I studied biomedical science at university, and it was there where I did a course on microbiology, where I just found the module and the work that we did really, really interesting, really, really fascinating. And when I looked down that microscope for the first time and saw we had it was just looking at a sample of like paramecium and some other pathogenic bacteria, all swimming around in the view of the on the stage of the microscope, and I was just watching this busy little world of microorganisms wandering about, and it just like, yeah, I want to do something like in this kind of thing. And so several years of very hard work at university, and then I was never that person who wanted to explore the world, have gap years, or do anything like that. I wanted to work straight away. I wanted to give back to the world. I wanted to contribute. I wanted to get a career going and pay my own way in the world. So I was very lucky, actually. I got my job within 6 something months or whatever it were from leaving university, and I started on just a lowly position that I had at the time, just very basic things, but then learning all the tricks of the trade and the skills necessary and the experience that they can't teach you. You gain that when you're on the job, and basically just years and years and years of hard work, graft, and working my way up and getting all that experience and everything, and just learning how a company is put together, and how, because I work in a factory environment, how that's all put together, and how different things affect different other things, which can give different outcomes, and if you make changes to things, and that can affect things, and it drove my passion for it. And I was like, this is the place I want to be. I never want to leave here because it's brilliant. It's interesting, and it's always there's always like a challenge that's presented to you, which you have to overcome, and you have to do the investigations, you have to do the work, and when you get that positive outcome, and the people who you're doing that work for, they get the results that they want, and then it all makes it all worthwhile, and you get that, you leave work sometimes feeling I made a difference. This is something I enjoy doing, and I'm making a difference. And yeah.
Yeah, so exactly. So I love the fact that you're talking about making a difference. It's good. Look, at the same time, I mean, it's a job. We do get paid. We support our lifestyle, but at the end of the day, you have more than that, which is, again, you're saying, it's a kind of mission, adding value to the people. And everybody who's watching or listening, whatever you do in life, as a job, let's say maybe you kind of working and still have astrophotography going or whatever. I mean, everything is kind of important, so it doesn't matter, like like the guest that we have here, he's a microbiologist, or you're doing something else, it doesn't matter. All the positions in life is very important. And again, just looking from the perspective of adding value to the society, which I love the perspective. So talking about perspective, I mean, how do we go from microbiological level to the cosmos level? Because that involves that includes kind of a few like perspective shifts. How do we go from microscope view to the telescope view? Can you talk about your personal experience? How did you get involved?
Well, for me, in addition to having a fascination with biology and my microbiology that I discovered at uni, I've always had, I think that was probably inbuilt in me even before that, the interest in, the universe and what's out there and everything. And I mean, how my microbiology ties in with, the cosmos and everything is, well, for example, I mean, while I was at university, I mean, all these discoveries they were making of extrasolar planets around other stars, and there's a new one that's been found in the habitable zone of its star. And from a scientific point of view, my mind would just like run away with me and think, how would life have developed on a world that would have very different conditions? And for years and years and years of looking at tiny little microorganisms down microscopes and studying biology, and how life on our planet's evolved to create the forms of life that we see, from the microscopic to the macroscopic. And it always fascinated me to, I'm sitting on the bus going into university, and I'm reading, one of these, Gliese 581 as a planet in the habitable zone. And you read about the environmental conditions that are possible on a world like that. And you think, how would life have evolved to adapt to its environment? And coming back coming back nearer to home in our solar system, the discoveries that we've made recently, like, I mean, potential for life on Mars, for example. I mean, we now know, after all the missions that we've, gone, sent to Mars and everything, follow the water. We found water. It had water. We know that without a shadow of a doubt. And we know from the history of our own planet that as soon as the oceans formed on our planet, life appeared. Microscopic, very, very basic microscopic life appeared very shortly after the oceans. Mars had oceans as well. It had a magnetic field, it had a heavy atmosphere. So, and we see those methane spikes in the atmosphere, which you cannot explain, if it was not based on a geologic or a microscopic source, because it would be destroyed by the rays from the sun, because it doesn't have a magnetic field and a very thin atmosphere now. So the methane gas of that level wouldn't be able to survive. So again, microbiologist, imagination runs away with me, and thinking, maybe, just maybe, there's life that evolved billions of years ago, but as Mars lost its atmosphere and lost its ocean and everything, it adapted itself to survive the current conditions. I mean, it's going to be microscopic life. it's going to be under the soil. It's going to have to be, because it can't survive on the surface. And I think that there probably is, based on what we've seen so far, and based on the history of life on our own planet. And then even nearer to home, you come to Venus, like the recent discovery that's been made. I know it's disputed now, apparently, but there's evidence that what was it called?
So fine.
Yeah, pro something or 9 or whatever it was. Basically, this this molecule that was found higher in the atmosphere of Venus, where it's actually relatively comfortable, about 20 degrees. There's water vapor in some shape or form up there, and it's not. I mean, again, as we know, Venus billions of years ago would have also been similar to Earth. It would have had oceans at that point, had a more kinder atmosphere to life, and life could have got going. But as Venus succumbed to its greenhouse effect, again, it could have evolved to deal with those conditions, and you could have had it adapt so it floats around in the upper atmosphere, and it feeds on the moisture, and then when it dries out, it falls back down, and then it picks up some more moisture and floats up again, or possible life cycle that some people have talked about. And then you go slightly further afield to the moons of Jupiter and Saturn, where they're basically glorified snowballs with oceans underneath. And we've already seen with the probes we sent there that there's an ocean, a kilometers deep ocean, that is mixing with the sediment at the bottom of the ocean floor, which means that you have liquid water that has dissolved minerals inside of it, which is everything life needs to evolve. I'm not quite as sure about life on those. Oh, it's possible, but it would probably be radically different to anything we would know, because I mean, these are sealed. The oceans are sealed by kilometers of ice. So, I mean, with Mars and Venus, you can get cross-contamination with asteroid impacts, blasting rocks between Earth, Mars, Venus, back and forth. But I would say if we did find life on the moons of Jupiter and Saturn, then it would be very different, I think, and possibly even Titan, the moon of Saturn, where it's got this thick atmosphere. I know it's very, very cold and it's all natural gas lakes and everything, but it's possible that there could be an alternative biochemistry. Again, that's the going back to my university days, where you learn about the biochemistry of life and how you have all the different biological molecular pathways that life uses, for photosynthesis and the ATP, how that's used to energy for cells. The gradients that you have that they exploit, and so forth and so on. And it's very possible that there could be alternative biochemistry going on there, which there is life, but not as we know it.
So that's a very interesting topic, because like what you're saying, even let's say on a Europa, one of the moons as well, that a lot of people I think there could be something there as well. And we're talking about water, which is again looking through our personal eyes, that's what it takes to create that life form. And again, and we found those life forms again. If you look at the like Mariana Trench, and I mean 11 kilometers deep, you're still gonna find not even the bacteria. We're talking about fish like existing with all this water pressure, and like it's pitch dark, and I mean they're evolved and they existing, and they living in those type of conditions. So who knows again what type of conditions would be on those planets. But so go ahead, do you want to top it up?
Yeah, I think it's I mean, we have potential stages for life to evolve. I think the question for me, it's if life can appear, will it? I think that's what we don't know, because all the conditions are there. It's if the conditions are there, will it appear? Were we and life on Earth just a freak accident that is unheard of in the rest of the universe, or is it like inevitable I think that's what we don't know yet. But if we find life on any other place other than Earth, then it will answer the question straight away that, yeah, if life can appear, it will.
Yeah. So again, that's a very interesting, thought as well, because when you start talking about again Mars, and basically there's a kind of proven photos, let's say so far, and through the rovers, and saying that there was water out there, and because of that, there could be possibility of, let's say, kind of bacterial type of life existing, and of course on other planets. So if we're talking about again the similar kind of conditions that helps to create life, let's say the way that it started here on the planet. So the thing is, are we going to be talking about exactly the same kind of bacteria, or do you think it's going to be completely different because again of the environment? And what do you think is going to be?
It would be some kind of extremophile, what in microbiology what we call an extremophile. So an organism that has adapted itself to survive conditions that it would kill any other organism. So, for example, on Mars, you could have, which would explain the methane spikes, you could have methanogens, which are a type of extremophile where they survive. You've got very little, you've got nothing but rock to live on, possibly water and ice underneath the soil. Would have to be quite deep underground. And the way they metabolize is they metabolize the nutrients, but they excrete methane, which is what we're seeing with our probes. We see it seasonally in very particular locations. So it's very possible that what we're seeing, if it's not some kind of geological process that we don't know of, it could be that there are microorganisms living under the soil that are methanogens, or the Martian equivalent of methanogens, which are excreting this gas that we can detect. And you have other examples where you have extremophiles that can survive radiation that would instantly kill instantly kill a human being. You have microorganisms that can survive boiling hot springs, very strong acids, high salinity, so brines, which we know we've seen brines, really, really salty water on Mars. And you could have microorganisms that, I think there was a study done in the last couple of years where they've discovered a particular bacteria, I think it's an extremophile, probably is, that is able to metabolize arsenic, which was a toxic substance to pretty much every other life form. And they're discovering microorganisms that have adapted themselves to have this alternative biochemistry. And with the extreme environments that we know of out there, we see them on our planet. So it's if life could have got going, then as we know from evolution, we understand evolution very, very well, that we know that life does adapt itself to survive very hostile conditions.
Yeah. So yeah,
it
could be potentially, because what I'm thinking, like there's this kind of stupid quotes are going around, but I don't want to say it because I think it could be a little bit offensive for a few people, and again it's for puppy lovers, but it's a stupid quote. But I mean, it's 4.6 billion years old. We're talking about Mars, let's say Martian specifically. And again, if you're going to look what's happening on the planet Earth, if you go and you see where those kind of volcanic activities going, I mean, you're going to get pretty, not dissimilar, but you're going to get some, kind of similar conditions that you're talking about. Of course, let's say if there's going to be water near the volcano, you're going to get the kind of, the what do you call it, the acid kind of in the water. I mean, it's going to be very hostile, for somebody, let's say, who's through evolution kind of lives in here, and we see like those objects and maybe some bacteria, in the ocean and around us. But there's still like existing bacteria in those environments as well. And we, of course, it's nothing to compare to the Mars, you know, and those type of conditions and the gravity, and again, there is no atmosphere, and again, it's a little bit more harsher, at least would say. But I mean, it could be that through that 4.6 billion years, it's just adapted, you know, because, and that's what I wanted to say, this stupid quote, because, you
Yeah.
know, it says if you're gonna hit somebody, they will adapt to that hitting, basically, you know. So it could be that, or it could be something else again, but it's still, you know, it's still to explore, and it's still to see, because we're a little bit still behind for some reason with all of that for now. But again, because I love the fact that you brought it up, because it's very interesting conversation. So besides that, I mean, on, let's say, on microbiological level, do you see any type of projects, let's say, involved with the space exploration that people should be aware of in the near future?
I'm just trying to do a mental inventory of missions that I'm aware of. I think so. Like, start nearer to home, Venus. I know that I think they're talking about sending a balloon probe to Venus, to the upper cloud decks. I think because that's where they have theorized that if there is life on Venus, that's where it will be. And based on, you know, this chemical that they've the molecule that they have discovered, or they apparently have discovered, it's slightly disputed now. So that could be one. I can't remember if it's got its go-ahead status yet, but I'll have to. If you Google it, you'll find it. And there's the probe on the way. There's the rover that's on the way to Mars now. What's it called? Is it Perseverance rover? I think. Again, if you Google it, you'll find out. It should arrive there in February, and I know it's equipped this time with a drill, which is going to drill down into the soil. I don't think it's equipped to look for current signs of life. It's equipped to look for signs that there was life. If there was life on Mars, I think it's equipped to be able to find it. And also another thing it's doing, it's got these suite of caches, little tubes that it's going to take it's going to take the drill samples it's put in these caches, and then it's going to just dump them on the ground. And then apparently they're talking about I'm sending another rover to Mars, to the same area as this rover will be, to collect the caches and then take them to a Mars ascent vehicle and actually send these samples back to Earth. So we could actually study actual physical samples from Mars. And that's going to be the only way we're going to find life on Mars, if it's there, is actually studying the actual deep soil. Either that, or until we actually get boots on the ground there, actually send people there to actually, you know, dig and actually, you know, get some manpower there to actually look in person. Elsewhere, I think they're talking about sending another probe to Enceladus. So that's a really little moon of Jupiter, Saturn, sorry, a little moon of Saturn, where they have these geysers, these jets of water that are coming out from the South Pole. And we've already had one of the probes fly through them, and it's detected, you know, the sediment that the minerals and everything that we know are mixing with the ocean underneath. And I think they're going to be sending an orbiter to actually go there and actually stay a while and actually equip it with special equipment that will analyze it for biological material, if I'm right. I might be wrong on that. I think that's what it's going to do, because Enceladus is looking like the most likely place, or the most accessible, because, I mean, the original idea years ago that, oh, we'll land a probe there, but then we've got to drill under kilometers of ice and actually swim into the ocean and have a look around. But we know now that the ocean is spewing out into space. So why drill when you can just send a probe and literally fly through it? So I think that's what it's designed to do. Off the top of my head, in addition to the usual suite of experiments that they do on the International Space Station, I mean, they do experiments on things up there all the time. There are too many to name, but I think that's all I can think of at the moment.
Yeah.
Regarding that kind of thing in space, yeah.
Yeah, that's perfect. I mean, you know, the projects, of course, that you're talking about is Enceladus. So again, if you Google that, again, one of the previous ones we talked about, because you know the Cassini, that was the probe that kind of passed, you know, Enceladus as well.
Yes.
And we're talking about the other one, which is Perseverance rover. As I mentioned, that's going to be planned. It says landing date 2021, 18 February. That's 8 o'clock.
Yeah.
8 o'clock. So here we go. The timing is very specific. Here you go. So again, and you mentioned one of the things that you talked about, kind of, you know, astronauts on ISS making, again, they're making a lot of different, you know, kind of tests and running tests and making sure that, you know, because there's a lot of different things that we can do in space, again, with the zero G. But from a microbiological standpoint, like, can you mention, let's say, one or a couple of kind of tests that are like important to us that are made on ISS currently?
You're picking my brains there.
If you have something to share, I mean, if you know, I know like we're not encyclopedias, you know, but I'm just saying from personal experience, maybe you come across something.
I'm not. Yeah, I admit I'm not really fully clued up with exactly what they're doing. I mean, they must be doing some microbiology related stuff up there, but I'm not familiar with any tests or experiments that they're doing up there.
Yeah.
The only thing I can mention is that I have read about from a microbiological point of view is I know that they have had the guys up there in previous missions have actually collected samples of microorganisms actually growing on the outside of the space station. I think I've got that right. Again, if you Google it, you'll find it. If I'm right, I'm pretty certain that they had taken some samples or whatever, and they found that there was, I think it was some kind of pathogen, might have been salmonella or something similar, growing on the outside of the space station, and they were like, you know, it again, you know, I think when it made the news, it was like, you know, the incredible resilience of life. It's growing on the outside of the space station in the space. And yeah, I think that's the only thing I can think of microbiology-wise that I know of the space station. There is another thing that's just come to my mind. This is going back years and years and years now, back to the 60s or 70s or whenever it were. I think it was Apollo 12, the mission to the moon, where, if I've got that mission right, it was either Apollo 12 or Apollo 14, where when they landed the lander just so it landed within a few feet of a probe that a surveyor probe that had landed a couple of years prior. And they actually walked up to it and they took, you know, bits of it and everything, and they brought it back to Earth. Oh, they tested it, or they brought it back to Earth, and they found that there was bacteria still alive that was able to be, you know, I think it was in a dormant state, but it survived years on the moon, and they brought it back and they revived them. And again, that made headlines that, you know, bugs can actually survive on the surface of the moon. And I can't remember what bacteria that was. But again, if you Google it, you'll find it, because I know for a fact that that's one thing that they did.
Yeah. So I see, yeah, there's on a website, Moon Microbe Mystery Finally Solved, and that was 2011. and of course
That's it. Yeah.
it will probably include a lot of those bless you, so a lot of those you know, names that I cannot spell that will be in Latin, but here you go. Make sure to go and Google and find that. Because again, those topics, again, we're kind of talking about the beginning of evolution, you know, like if we're talking about the microbes, again, at the same time, we cannot see them, like unless it's through microscope, but at the same time, it's very exciting because that's how it starts. So besides that, I mean, what is your personal take about, you know, because again, a lot of astrophotographers or just scientists and people just like yourself, I'm sure get asked a question about extraterrestrial kind of existing life form out there. So what is your personal take on that? Do you think something exists there, there's not existing, and why?
My personal opinion, I mean, you know, looking at it from a scientific point of view, based on the data that we have so far in the rest of the universe. So we have discovered thousands now of extrasolar planets around others. We know now that pretty much every star has at least one planet, and we already have estimated, based on what we found so far, that there must be at least 400 billion Earth-like planets in the Milky Way. Now, that's very exciting, but when you look at the search for I've lost my words, for ET, you know, intelligent extraterrestrial life forms, we have not seen anything, nothing. I mean, you know, the occasional UFO sighting and stuff aside, based on scientific data that we have collected, nothing. No radio communications, no obvious alien technology. I mean, the WOW signal at Arecibo, I think that's where they received it, which unfortunately is going to be dismantled, which is a big, massive shame. I think it was Arecibo, where they discovered the WOW signal, and they were like, "Whoa, what's this? A radio blast in our direction?" But that apparently they could explain by a mission by a pair of comets or something Earth-related, reflecting off some space junk or something. And then there was Tabby's star. Now that made headlines a couple of years ago when they noticed it was dimming really bizarrely, and they were like, "What's going on here?" And they looked at it, and some of the theories were, "Oh, there's an alien megastructure in orbit around this star, which is collecting its energy and so forth and so on." But then they kind of looked at it a little bit more, and they thought, "No, it's dust. It's just natural space junk and just dust and asteroids and everything, which is in a weird sort of blocking it out in a weird kind of way." We have seen no evidence at all of anything immediately obvious, at least in our neck of the woods in the galaxy. So based on that, I personally believe that life, because of how we know that life appeared so quickly on our planet as soon after the oceans formed, we know now that there are planets out there that are going to be in an area around their star where liquid water can pool on the surface. We know that now. We see that. Not directly, obviously, but we see it. So I believe that primitive life is very common. Very, very, very common. But intelligent life, we just haven't seen any evidence of it at all. So based on that, I have to conclude that it just seems like it just primitive life, maybe like complex life, like animals that have adapted, like we were talking about earlier, you know, that unique creatures that have adapted themselves to their environment. Maybe we're the first. Maybe we're the first one in our neck of the woods to achieve the intelligence to be able to look at one part of the universe and wonder about it. But then I guess you look back at the history of life on our own planet, and it could be that, I mean, scientists talk about this, the great filter, which is where they kind of relate to the Drake equation, you know, which estimates the number of intelligent civilizations in our galaxy, which ranges in size from none to billions. And you could have, I mean, with the history of life on our own planet, life on our planet was almost wiped out on at least 5 major different occasions, the worst one of which was the Great Dying back in the Permian period, about 250 something million years ago, where pretty much most of life on Earth died out. And it's like the universe has tried to kill everything on our planet on numerous different occasions, like, you know, the asteroid that wiped out the dinosaurs, the Great Dying. And
so if you don't mind me asking, what do you think personally about 2068? And again, you know, right now scientists are trying to kind of talking about options of deflecting asteroids, and again the kind of recurring name that probably came across a lot of people, Apophis. So that's 2068 kind of prediction. So what is your personal take on that?
I would imagine by then we could probably, if it was a threat and if it was going to cause problems, we'd probably just blow it out of the sky, I think. Or we might come up with another method. Maybe we might. I think I listened to a YouTube documentary about this, where they came up with different ways of deflecting, where they painted one side of it like black or something, or white or whatever it was. So when the sun was hitting it, the color of the asteroid made it deflect its orbital path, and so they deflected it like that, or they nudge it out the way, or just nuke it or something. Yeah, I would imagine that. I mean, we've got defense. They've got all sorts of things that they have in place that they can do if they just have to refer back to the movie Armageddon, basically.
Just split it, drill it, split it. That's it. Problem solved.
Yeah. Take a drill armed with a machine gun.
Yeah.
Yeah.
Look, could be. I'm saying, you know, like there could be something existing that will help to deflect. Because again, we cannot.
Oh, I'm sure there is.
We cannot depend on Jupiter's gravity all the time to make sure that, you know, Jupiter is going to deflect all the asteroids for us. We have to have kind of our own system to make sure that we can protect ourselves, and you know. But hey, something to look forward to and see how the scientists and, you know, people are gonna make that problem go away. Because it looks like it's a problem. Well, hopefully it's not 2020. It's not happening this year. So again, personal experience, coming back to astrophotography, can you talk about like what are you currently working on when it comes to equipment?
So my equipment that I have, it's an evolving process for me. So at the moment I have my sturdy tripod, star tracker, DSLR camera. That's my gear at the moment. So at the moment, I'm primarily nightscape work that I do, and deep-ish sky work that I do, because the biggest lens that I have at the moment is the Samyang 135mm. So that's, I guess the way to think of it for people who aren't quite as clued up is it's like a really, 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 really diddy kind of sort of telescope. So I mean, shameless plug. If you go on my Instagram or my other social media, you'll see some of the deep sky. I mean, my thing with deep sky is the nebulas, the emission nebulas, and you know there are so many different, you know, examples of these wonderful things in the night sky that I aim my lens at, and some of these nebulas are just big enough with the size of the lens that I have that fit really nicely in the frame, and that's kind of what I'm working on at the moment. I have not yet got a telescope, a proper like legit telescope, but I am looking to eventually go towards telescope territory.
Mm-hmm. No, that's perfectly fine. I mean, it's one of the kind of advices I think that people, when they see these shows, they get most of the time for the beginners is just to buy probably a little bit more decent mounts that you can build
Mm,
on, that you can go from DSLR to maybe a little bit heavier equipment again for a heavier scope and upgrade from there,
mm.
you know. But that's what they recommend. You know, it's a great way to get started. You know, just with the mount and
Yeah.
DSLR. So with that, can you again talk about let's say the camera best type of camera settings for astrophotography?
So for a DSLR, which is again what most people usually start with, so for a nightscape, for example, you're looking at it. It does depend on your light pollution, though, because luckily where I live in the countryside in Norfolk, I'm what I would what is classed as Bortle 4, which is fairly dark.
Mm,
So if you're under that kind of sky, if you know you're in the countryside, you're at a dark site, fairly in a fairly dark sky, you would want for wide field something ISO 1600, maybe even 800. 800 to 1600 is what you would want. You would want, if you don't have a star tracker, 30 seconds. That's the maximum that you can put a camera to, because the other thing that people with DSLRs need to be aware of is the 500 rule, or what the 500 rule, which is where if you do a timed exposure of the night sky, and as we know, you know, the Earth rotates, the sky is rotating. If you expose for longer than 30 seconds, you will start to see star trails. And the 500 rule is where you can work out when you would start to see those star trails based on the lens that you have and based on the time you expose. So that you know you use that formula to dictate how long you expose for. So if you have like, I don't know, a like I use a 14mm to do a lot of my wide field nightscape shots. So yeah, Samyang 14mm, really great lens. Um, 30, anything beyond 30 seconds without a star tracker, I start to see star trails. If you got a bigger lens, say, I don't know, 100mm, you'd probably see star trails. I mean, I'm just thinking off the top of my head here, you probably would start to see star trails at about 15 something seconds. So again, that limits the bigger your your lens, the less time you'll be able to expose for without a star tracker. So for deep sky, you're going to need a star tracker, like 135mm or bigger. You'll start to see star trails after just a handful of seconds. So you need to have a star tracker. Once you have that and you polar align it properly and you set it up properly and so forth and so on, you can expose. I mean, the longest I ever did was 4 minutes. And the amount of time you can expose for really makes a difference in the quality of the image you get. The more light you can collect, the more data you have to play with.
yeah. So coming back to the mount, can you talk about again the differences, let's say, with the altazimuth and equatorial mounts, and what people should buy in the beginning?
So if you're just doing, you know, starting from the very, very beginning, like I did, mount, camera, that was it. And basically I would just aim it wherever I want. So basically that's, you know, move, or ball head, you know, moving it around wherever you want. With a star tracker, so the one that I have at the moment is the Star Adventurer star tracker. And that, you'll have to forgive me because I'm kind of like not as clued up on the terminology, but when you mount your DSLR, you can the actual mount only moves clockwise, anti-clockwise.
Mm,
You can move your camera on the top around, but the mount doesn't have the ability to move in that. It only literally moves in the tracking motion.
mm,
So that's the one that a lot of people do start with. And then when you get the go-to mounts, which a lot of people, I mean, the one that a lot of people use, probably the one I'll be getting, is the Skywatcher HQE Pro VXW25 something or whatever it's called.
It's a lot of letters.
Yeah, I can't remember what. I think people watching this will know which one it is. The the 5 Pro, I think what it is called. So it's a go-to mount that moves, that you can move clockwise and anti-clockwise, and also shifting in that way as well. I can't.
Yeah,
They're like a real div. I can't remember what the terminology is.
Look, that's fine. So again, sorry for maybe asking those, because again, I just want to
No,
say,
you're fine.
because personally, I'll tell you, I'm not an expert in this. I think you're doing a fantastic job when it comes to astrophotography. I mean, it's a learning curve. It's a learning curve for everybody. But you know, coming back to that, so again, there's the Skywatcher NEQ6 that a lot of people talking about. They have that. That's kind of very heavy duty mount that you can build on. And I mean, there's so much more equipment. And again, people can go and check it out, what type of equipment and the mounts you can buy. But what would you recommend for the beginners? Let's say they're watching this from UK. So where did you bought your personal equipment? Can you mention a few websites maybe?
So going from really quickly, so I have a Canon 6D Mark 1 full frame camera. I bought that from Argos. So they were selling it at Argos at the time, so I ordered it. They got delivered. I have a Manfrotto Pro 055 mount, aluminum, not carbon fiber, because I'm not made of money. And I got that from Amazon. No, I didn't. Tell a lie. I got that from what's it called? It's a company in Norwich. Wex Photo. Heck, I can't remember where it's from. I think it's Wex Photo. And I got the Star Tracker. So the Star Adventurer. I mean, there are other Star Trackers. There's the Ioptron. There's a couple of other, I can't remember, but the one that a lot of people use is a Star Adventurer, Star Tracker. And I got that from, now there's a company, as we were just talking off camera, in my local area, sort of Ely way, there's a company called the Widescreen Centre. So for those people who are based in the UK or based in the Norfolk area watching this, who are interested and you want to get some gear, the Widescreen Centre is basically your one-stop shop for telescope, camera. They even do, going back to microbiology, they even do microscopes, believe it or not. They do all sorts of things, and that's where I got my Star Tracker from. Now, this was a couple years prior to now. Obviously, in the glorious days before lockdown, you were actually able to go to the Widescreen Centre, and I had a chat with the owner about, because I had a different mount at that point, and I wanted to know if the Star Adventurer would attach to it, and I found out that it didn't, so I needed to get a more suitable mount, and so that's where I got that from. I got my lenses, so I used the Samyang / Rockinon. I mean, they're both the same thing, but I don't know why they're called a different thing. But they're the lens. I mean, I did my research, looked at what other people are using, and they all recommending Samyang lenses because they're really affordable, but the quality is amazing. The image, I mean, for example, look at the stuff that I've done with them, and they're really simple, easy to use. They're full manual lenses, though. They don't have any electronic, manual focusing or anything like that, or automatic focusing, sorry. And I got them from Amazon. And some of the other more recent kit that I I had my Canon 6D modified. Now you're probably wondering, well, modified, what do you mean by that? Canon cameras have a special filter inside the body of the camera on the sensor, that if you remove it, you can pick up the red emission, the red color of the emission nebula so much more than if you had that sensor still attached. You can do it yourself, but I'm kind of an idiot, so I was like, no way am I doing that myself. I mean, there are people based in the UK that the guy I used, Astronomizer, as I use. Really nice guy, based in Nottingham, I think it is. And, you know, we got in contact. I told him what I asked for, and, you know, he said, okay, this is how much the service will be, sent it away, got it back, sensor removed. So it, and I tested it out, never looked back. If you're wondering about getting your camera modified, do it, because what you can do is you think to yourself, oh well, I've modified it so I can't use it now for daytime. You can if you buy a filter. So if you remove the internal filter, but what you can do is you can get a clip-in filter that is the same filter that would have existed previously, but you can actually click it in to the body of the camera yourself. So then you can now choose, I want it for astro, take it out. I want it for the daytime, put it in. Simple as that. And the most recent other filter that I got was a hydrogen alpha filter, which is a same thing, clip into the body of your camera, and that's that picks up the emission nebula of the night sky even more than ever if you just did it without a filter, because it just is designed to pick up that wavelength of light. It cuts out moonlight, light pollution, and gives you that amazing detail that you wouldn't be able to get otherwise. And those filters I got from the widescreen center as well, and that was during lockdown, so I had those personally delivered. Just thinking, is there any other kit that I have? Just other random things like an intervalometer from Amazon for a couple quid. What else? I think a Batanoff mask that I had actually 3D printed for my Samyang 135mm. Now I can't remember who that was at the top of my head. There's only one person I know of who does that. If you Google it, you'll find it. I can't remember what the name of it is now, but there's a guy who 3D prints them for you.
Yeah,
I think that's all my kit.
Yeah, so I actually had a guest before on a show, and that's for people. Let me see if I can find it right quick. Because one of the guys that I had, he actually, when I spoke with him on Instagram, he said, "Well, I'm just." I said, "What are you working on?" He said, "Oh, I'm just working. I'm just printing a Bactronov mask right now," and he has a kind of heavy duty 3D printer. And again, for the people who are watching, you can find him on Instagram and connect with this man as well. So I don't know if I'm gonna find this man quick, but yeah, I mean that's doable. So basically, maybe you can even buy your own 3D printer if you're gonna be using it a little bit more often. And so here we go. I think I found the man. So just give me a second. So here we go. So Astro Philip, that's Astro_Philip. And again, yeah, so he does that. So anybody who's watching, maybe you want to get in contact with Philip, but I don't know if he can provide this type of kind of service for the people who are watching. But you just have a conversation, and you'll get some value from that. So again, the website that you mentioned, widescreencenter.co.uk, and again, I'm looking at it. So yeah, the 2 Rosemary Lane, Satana Ely. So again, people are from there, and of course, right now you will get online shipping, which is good. So at the same time, again, there's a lot of kind of behind the scenes work when it comes to stacking and post processing images. So can you share some of the softwares and maybe pros and cons while using these softwares against other softwares available?
Yeah, so that's the other thing that was a big learning curve for me is, getting a little bit more in depth in the hobby is, yeah, you're going to need to have some processing software. Now I know that there's, so for my wide field, for my nightscapes that I do, I use Photoshop. In the beginning, I used Lightroom just on its own, but Lightroom and Photoshop come as a package. I mean, so you can, you buy them as a pack, you have a subscription to them as a package, and it's 10 quid a month. Yeah, I had to watch numerous tutorials on how to do certain things, how to edit them. And with stacking, what I tend to do is if I do a nightscape, I go to the area I want to do as my scenery. I take my shots, and I take numerous exposures so that I can stack them together, and then I either move slightly in a different place in the same area, so I kind of have a bit more of a clearer view of the night sky and take images of the sky that I want. Or I might just walk further down the road, or a similar area that's a bit more clear, and I take my images that way. And so the stacking software that I use, for my nightscapes, I use Sequitur. Now I have a Windows PC. I know on a Mac it's Starry Landscape Stacker, but for a Windows PC it's Sequitur, Sequutar, Sequitur, I think. And it's a free software, totally free, no license needed or anything, free download. And it's really simple to use. And you just, so what I do with my my nightscape, my landscapes, I put my foregrounds in there, and I stack my foregrounds in Sequitur. And with my sky images, what I tend to do is I used to use Sequitur as well for the sky images, but there's another program that's more well known in the astrophotography community called Deep Sky Stacker, or DSS. I think that's for Windows. I'm not sure if it works on Mac. I think it does. I can't remember for certain. Now, lots of people use this one. I use that now for my Milky Way, like star shots. I stack them together, and then what I do is I merge them both together in Photoshop. So I had to learn how to do masks and mask out the blurred stars of my stacked foreground, and then blend in the image of the tracked sky that I did. And I always make a point of saying that with the nightscapes that I do, not all of them used to be. When I used to do just single images off the camera, obviously it was that particular, shot. But when I stack them and merge them together, I always say because I always give the information in my EXIF data is, that it was a blend. It was taken in the roughly same area and blended together. Because I know if you did a foreground and then you drove, I don't know, 100 kilometers down the road to a dark site and did it that way, and say, oh yeah, I took that in the same area, I wouldn't want to do that, because that wouldn't be honest. So with my deep space astrophotography, so where I now got my heavy, my bigger lens, I'm on the star tracker, it's polar aligned, and I'm doing like minute or 2 minute long exposures. I'm putting all my images into this deep sky stacker. Now, another learning thing you have to do alongside of taking what we call light frames, so that's all the the data, the actual images of the objects you want to do, you have to do dark frames. So you have to put the lens cap on, you have to do, I don't know, 20 something dark frames. You have to do bias frames, so basically you set your camera to the lowest possible exposure, like 1/400th of a second, and do like 50 something odd of those. Then you have to do, because with any lens or any telescope, you will get vignetting and or dust particles on your sensor or on your glass. So what we do is flat frames. Now, the way I do my flat frames is I turn my gear upwards, so lens is pointing upwards, take the cap off. I put a white t-shirt over the top and put a rubber band. I then have it's a tracing pad. Now that's another bit of kit I got off Amazon, a tracing pad. You plop that on, attach it to a external battery pack to power it, and you turn the light on, and then what you're probably thinking, why are you putting a white t-shirt around your gear? That diffuses the light, so you have a flat frame that shows you where the vignetting is and highlights the dust particles if there are any. And then what you do is you take your shots, and then you put your cap back on and leave it at the same settings that you had it. And then with Deep Sky Stacker DSS, you put all of those images, your lights, your flats, your darks, your bias, your flat darks, you put them all together. The software will work out, what it needs to do. You press go, and it stacks all of those images together and calibrates the images using all the dark frames, the flat frames, so forth and so on. And then it spits out a perfectly clear, clean, smooth image, no vignetting, no dust particles, no hot pixels or anything, a perfectly clear image that you can then export into Photoshop and start editing. Now, there are numerous tutorials on YouTube, and that's how I learn. I'm no professional. I don't have any qualifications. I didn't do any courses. Everything that you see on my Instagram and my pages, all the work I've done, I've been self-taught because of, for example, Astro Backyard. Now, he is the big dog in astrophotography. This guy is the king of the astrophotography community, or one of the kings. He does tutorials on his YouTube channel that I use to learn to how I do what I do, and there's numerous others that Astro Exploring is another YouTuber who does his own tutorials, and oh, there's a German fella. What's his name? I can't remember what the name of his channel is. Is it the, like, other people will probably know who I'm talking about? A German fellow. I can't remember what the name of his channel is. He does tutorials. There are other software that you can use. Another one that's mentioned a lot is PixInsight. And I've looked into that. Now, you do have to spend a bit of money on that. I think it's 200 something of your finest British pounds. And it is, you have to buy the how-to guide, or it's very complicated to use. And I class myself as a lazy astrophotographer. I just like to be able to have a really simple to use software like Photoshop, really, quick edits, nothing too complicated. But with PixInsight, you really do get what you pay for, but you really, really have to dedicate time to learn exactly what you need to do, because you have to put in different like code formulas and different. It's for me, it's just. So I'm a Photoshop guy at the moment. I might go to PixInsight in the future. I'll see how I get on.
Got it. So again, for the people who are looking to learn more about PixInsight, another guest that we had on the show prior to yourself, Michael Collar, and you can find that episode. I think it's episode 13. So he wrote, again, he went through the same process. He kind of taught himself through, tutorials and videos on how to use PixInsight, and then he came up with a kind of his own personal take, and he wrote a book. I don't know how many pages it's going to be there, but you can go and find it on iTunes kind of bookstore. I don't know, if you go to episode 13, you're going to find the link for the book. It's called PixInsight Guides or something like that. So again, how difficult is for the people to learn, how to use Photoshop? Because let's say for the people who never came across any softwares like that, and again, if they're compatible with, depending on if they're using a PC or they're using Mac, because again, funny enough, Mac kind of one of the original screensavers that you see, it's Andromeda, but and they don't allow let's say the deep sky stacker softwares to kind of use with the Mac as well, or maybe they do, but I mean, it's a little bit funny. But like how much does it take, let's say, to learn Photoshop, kind of simple post editing like type of techniques?
For Photoshop is probably definitely where I would advise anyone to begin with. I mean, actually tell her, like, Lightroom is the one I started with, and it's the most easiest to use. Is that you load your image in, and it's sliders, mainly sliders to increase contrast, brightness, make the shadows brighter, darker, make it more saturated, so forth and so on. Lightroom is the software that I would recommend people to start with. It's so basic and so easy to use, and you're just using sliders basically, and then save image, boom, easy peasy. Photoshop, obviously, you have a lot more functionality. You have a lot more control over your images, and yeah, it does take a little bit of it is a little bit of a learning curve. I would say probably couple weeks worth of watching tutorials and just playing around with old images, just to understand certain concepts that you use in Photoshop. And like really quickly, what I do with my nightscapes, for me, masking was it was at the beginning, because you have to learn, how do I select my landscape, and how do I mask out the sky and do that sort of thing? How do I make the stars smaller? How do I select certain bits and so forth and so on? In fact, for me, it was such a learning curve that I'm not afraid to admit it, but I watched the YouTube tutorials and I took notes. I took physical notes, because what I used to do is I would have my image, I'd be editing, and I'd be watching the YouTube tutorial at the same time, and I'd be like, right, I need to forward to that bit and go. And for me, what I did is I just wrote down like the key bullet points of what I need to do, and that helped me sort of get to grips with the more commonly used functionality. And then basically it then just comes with experience. The more you use the software, you'll retain the information. And it's got to a point now where I open it up and I know what I'm doing, because I've read my little notes so many times that it's now in here. Yeah, so once you get to grip, I mean, they're not, I mean, once you understand the concept behind, what you do with these bits of functionalities in Photoshop, and then when you're able to, I mean, what I would suggest with people is understand, like, what are you looking to do? Minimize your stars, make certain bits brighter, make things stand out, or mask this bit out, or whatever. Once you understand how to do that, practice. Get some old images and just practice on them. And then that's what I did. I just practiced. I tried out new things. Just because someone says something in a tutorial, oh yeah, do this and it will look like this, doesn't always necessarily mean it'll work for you, or it might look different than what you would expect. So it's a trial and error thing. And that's what I did. I tried out certain things and I was like, yeah, that's great, so note that down. Or no, I didn't like that, so I won't include that or anything. And yeah, that's what I did. But again, it's an ongoing learning curve, because every now and then you have something new come out, like an extra add-on, or Photoshop adds a new feature that you have to learn and try out and everything. Yeah, but yeah, if you like practice, it took me about a month to get used to it, I'd say.
Mhm. Got it. So yeah, so the learning curve, I mean, in astrophotography, just anything, if you are thinking about, which I definitely encourage you a lot, people who are watching or listening to this episode, to get involved with space-related projects, and it could be astrophotography, something else. I mean, just take those steps, and again, get in contact with people just like Michael, or the people that have had previously on the show, and ask them questions. How do you can get started as well? But I mean, like for me, when it comes to personal journey, like with all the information and the knowledge that you currently have, what would you give yourself, kind of, when you started? What advice would you give to your younger self when you started, for, let's say, equipment or post-processing?
Get Photoshop. Get Photoshop.
Okay.
Without shadow of a doubt, get Photoshop, because it's once you understand how to use it, it takes your work to another level, because what you can do with it, what you can do with your images, it separates the men from the boys.
Yeah, so that's, again, if you want to like go and see Michael's photos, you can go to the astrophotographer m.wilson underscore astrophotography on Instagram, and of course you're going to see what type of work he does currently when it comes to that. And again, yeah, so Photoshop is a good advice, because again, with the PixInsights, as you mentioned, or unless if you're a beginner and you never used Photoshop, maybe you want to go straight to the PixInsight, but you don't want to go to Photoshop and then go into PixInsight, because you're going to be very confused after. But again, so talking about your current projects that you're going through, and I mean, the people can see your personal work on Instagram. What are the future, like near future projects that you're looking forward to as well?
So providing they survived, I have a couple of solar graphs that are going to be taken down the winter solstice on the 21st of December, because I've had them up for or when I take them down at that point, they will have been up for 6 months, and I've posted a couple already, which have been either tampered with or vandalized, so they didn't get the full time. So I've got a couple of those coming up. I mean, I would love to say I'll have some more nightscapes and deep sky images out, but that's all dependent on the weather, and we all know what the British weather is like. Totally clear nights are relatively rare. So yeah, so I've got a couple of those coming up.
Got it, got it. So I mean, it doesn't compare to the weather that we're having here, but okay. So so again, when it comes to the future projects, can you mention again a few kind of space exploration or related projects? And we kind of talked about some of those in the beginning of our conversation. Again, Perseverance, and there was Enceladus, again a Life Founder mission, and again more than a few. I mean that we talked about. But what other kind of space missions, excluding the SpaceX recent launch to ISS, that you're kind of looking forward to as well?
I would love to see a moon landing in 2024. I'd love to see that, because I wasn't alive during the 60s and 70s, obviously.
Yeah.
So I didn't see them. Although I've recently seen that it's probably unlikely. It'd probably be more like 2028. But just in the next couple of years to see, man and now woman back, or for the first time, a woman on the moon. Big shout out to the girls out there.
Yeah.
Is to get people back to the moon, because I personally think we need to do that, because we're talking about going to Mars, but if we're going to Mars, it's not you go there for a couple of hours and you come back. If you're going to go to Mars, you need to stay there for a couple of months. If you're going to stay there for a couple of months, you need to live off the land, and we need to be able to do proof of concept that we can do that. So rather conveniently, we have a moon 3 days away. We've been there already. We know how to get there. What we need to prove we can do is extract the resources and be able to use those resources to maintain, a little colony or a little base. Extract, we know there's water ice. We know we can separate, hydrogen and oxygen to make rocket fuel. We can do things with the regolith, the lunar soil, and we can build, things with it. We can use it for different resources. If we can prove we can do that on the moon, then we'll be ready to go to Mars. So I'm really looking forward to seeing a 21st century moon landing and a base. That's something I'm really looking forward to.
Yeah, that's very exciting. And again, yeah, so the mission that you're talking about, this Artemis mission, and people can go and find more information about that as well. I mean, it's fascinating again, because moon, I mean, it's definitely closer, and it's faster, could be possibly faster done. And we had prior guests on episodes that are working with these missions and building different projects. Again, when it comes to Mars colonization and moon base and hospital kind of creation projects, so we can find those episodes as well. So again, it's very fascinating. Yeah. So what's coming up in the near future? And I'm always kind of sitting in my chair on the edge, because I feel like something special will be happening very soon. Again, part of that again is Artemis mission. So, I mean, knowing what you're currently knowing, again, and you expanding your personal view and, getting more information about astrophotography, because as I said, it's the learning curve is infinite. And we have people who've been doing astrophotography for 50 years, and they said exactly the same. You're going to learn a lot still from a beginner if you're 50 years experience in astrophotography, which is crazy, because there's so much more to learn. But what is your personal, like a legacy part? Do you want to leave like a footprint, behind, again, what you do? I mean, it could be with microbiology or space photography. Do you want to leave like a personal legacy also?
I would like to like the nightscapes that I do, like of my local area that I do, you know, have nightscapes that show my local area that no one's ever seen it in that way before. I think to have a legacy where, oh yeah, you know, this is what this place that, you know, people see all the time looks like, but at night with the Milky Way blazing in the background. And I think for me, what excites me the most is that I have those images out there in the universe that I did that. Nobody else, nobody else has ever done that. Nobody else has ever been to some of these locations and done what I've done. And that's something that no one can ever, you know, I mean, people will probably follow, you know, we'll probably have a couple of other people, but as far as I know, there are some locations where no one's ever been in my local area to do this kind of thing. And it's nice to think that, you know, as long as the internet exists, that, you know, that's the contribution that I made, and that's the contribution that, you know, that's the first time anyone ever did anything like that, and that was this guy who did that.
Yeah, and that's beautiful. And again, part of the legacy is putting your content out there, which I highly recommend for everybody who's watching. Go on and get in contact with this man right here and follow him again on Instagram and see his work and become part of his journey and legacy. Because part of that, again, legacy part, I think personally, and that's why I wanted to have you on the show. That, you know, you personally putting out these photos and your work on Instagram and social medias, it's the way, you know, it impacts people and it inspires people to pursue their own, you know, astrophotographer or something else related to the space projects and space exploration, which is great. And that's why we need more people just like you, Michael, which I, you know, really appreciate you again coming on today and sharing your personal journey, passion behind it. And again, I love the fact and your take again on kind of microbiological level, what's happening out there when it comes to, you know, going and kind of living on different planets, or is there life out there, you know, as well. So it's really awesome. I mean, it's very inspiring, so thank you for that.
Thank you very much, mate. Really appreciate that.
Thank you. So guys and girls, as always, want to ask you one thing: if you share this episode with a friend of yours, and it has to be any friend, to pick one, your favorite, and send this over episode, help them to kind of broaden their personal view and get them inspired with what's happening right now with the space exploration, again, astrophotography. There's a lot of great future projects coming up as well. So again, make sure to get in contact with Michael too if you're looking to get started in astrophotography. Go and ask him questions, because again, the current equipment that he's working on, which I'm sure he will update over time, is perfect for the beginners. So ask him those questions. How do you get started as well? Again, Michael, thanks again for coming over today. And as always, I'll see you next time. And don't forget, guys, keep exploring.